3.8 is probably, potentially, the most challenging section in this unit. And we actually have nothing on our Cornell notes for 3.6, solving literal equations. So um, solving a literal equation is similar to solving any equation, except if you look, right away you see we have two different variables, and we want to solve for one variable. Now this is something you may have seen last year in pre-algebra, solving for y so that you could graph it using slope-intercept form. So we'll start with that because that is probably something you have seen, and then we'll move into the ones that maybe you haven't seen before. So if we want to get y alone, okay, we want to get y alone, we need to do this just as though we would do the problem 3x minus 4. Let's say it was 3x minus 4y equals 7. So if we had this problem, 3 minus 4y equals 7, and we wanted to get y alone, we would move that 3 first. The thing that's furthest away from the y would go first. And that is the exact same thing we will do here. So the one that is touching the variable is the last one to go. So this guy we're going to move as an entire unit. So in this problem we would have subtracted 3 from both sides. Okay, and we will do the same thing, but this time we'll subtract 3x. So these will drop out, and we're left with negative 4y equals. Now here, you could bring down the 7 first or the 3x. Both would be correct. I'm going to suggest we always bring the x down first. It's not wrong if you don't, but it will lead us into slope-intercept form a little bit nicer. So the negative 3x would come down first, and then this, since it has no sign in front of it, is understood to be a positive 7. Now, one of the most common mistakes is to actually write 4x. So remember, these are not like terms because this one does not have an x on it. So we can't just subtract the two and put them together. They are two separate. So the other option you could write is 7 minus 3x. If you wanted to write that here, 7 minus 3x. That would still be correct. Now we still need to get y alone, so we need to divide by negative 4. Now if I divide by negative 4, there's two ways you can do this. Divide the whole thing by negative 4, but what we're going to do is divide each piece by negative 4. So they'll drop out here, and we get this, negative 3x over negative 4, which is a fraction, which we can leave. But since it's a negative divided by a negative, we need to change it to a positive 3/4, and then we're going to bump the x behind the fraction. And then for this one, 7 divided by negative 4, I don't care if you leave that as a mixed number, that's fine, but a positive divided by a negative would be a negative. So we'll just leave that as minus 7/4. These we will not put in set notation because we are not solving to get a single value. We are just kind of manipulating this to get a single variable alone, and then we get an expression on the right side that it's equivalent to, not a whole number. So no set notation on these, okay? So that should look somewhat familiar because eventually this is going to be our slope, and this will be our y-intercept. So this is slope-intercept form. Y equals mx plus b. That should ring some bells there. But this one is a little funkier. All right, this one says we need to solve for x, and you can see we have an x on the left side. We also have an x on the right side. So in a problem like this, the first thing you want to do is collect all the x's together. And generally, when we have them on opposite sides, we want to move the smaller of the two. This will work in our favor here because the smaller one is the one on this side. If the 6x was the smaller one and we were moving it and it left a 0 here, I might say that's a bad idea. So we want to try never to leave an empty space on one side of the equal sign because that's where people make mistakes. So this is good because we're going to move this one because it is the smaller one. So instead of subtracting 3x, we will add 3x. This drops out. We get c equals 6x plus 3x, which is 9x. And then we want to solve for x. Remember, you have to keep reminding yourself which variable you need to solve for, because some of you may stop here and go, oh, I'm done. But we're trying to get x alone, so we're going to divide both sides by 9. So we get c over 9 equals x. Now, because we're not putting this in set notation, you can leave it just like that if you want. It's totally up to you. Or if you want to flip it over, you could do that also. So either of those is completely fine. But like I said, you have to keep reminding yourself which variable you're solving for so you don't accidentally solve for the wrong variable. All right, next, number 3. Negative 5a plus y equals negative 54. We're solving for a. So we want to get a alone. And remember, the key is that the one that the a is attached to, that's the last one to go. We're always going to undo the addition and subtraction first. And so that's going to be the one that's not attached to it. So this plus y. So the opposite of that would be to subtract y. So we get negative 5a equals. And again, I'm going to encourage you to always bring the variable down first. Remember, these are not alike, so you're just going to write them horizontally next to each other. So negative y and then minus 54. You can't squish them together into one term. And we're solving for a once again, so we're going to divide each piece by negative 5. So we get a equals. Now here's an important part. A negative divided by a negative is a positive. You always have to fix that. And you can either write y over 5, or you could write 1 over 5, because there's an imaginary 1 here, and push the y to the right of it. Both of those are acceptable. And then again, we have a negative divided by a negative, so that will be a positive. And 54 divided by 5 does not reduce, so if you like, we will just leave that as 54 over 5. You do not need to change that to a mixed number. You can leave it just like that. All right, number 4, we're solving for z. And there's a z on the left side and a z on the right side. So we need to start by collecting all the like variables on, well, the like z's on one side. So we'll move the smaller z over by subtracting 2z. 4z minus 2z would be 2z. The b is still here. These are gone. The c is here. All right, then we refocus. We're still solving for z. So we want to undo addition and subtraction, not the thing attached to the z, but the other thing, the b. So instead of adding b, we will subtract b from both sides. So we get 2z. These drop out. And these are both variables, so you can write them in any order you want. So it kind of makes more sense to write c minus b. Again, we're getting z alone, so we have to divide by 2, divide by 2, divide by 2. And you can just leave this, c over 2 minus b over 2. Totally fine. Okay. Another option, you could write 1/2 c minus 1/2 b. So we have some options here. Here I put the put the fraction in the front, push the variable to the right. Here I left them on top. They are both correct. So whatever you're more comfortable with is acceptable. Okay, that's fine with me. We've got 2 left here. We want to solve for y. Now, we see this fraction. We have to still get rid of that 3 in the denominator first. So we multiply by 3 over 1 on this side and by 3 on this side. Remember, in this case, the 3 cancels with the 3, and all we're left with is the numerator every time, y plus a. And that's equal to 3 times c, or 3c. Refocus again. We're solving for y. I always remind myself after each step what we're solving for, and that should be easy. We just need to get rid of this a. So we subtract a from both sides, and we get y equals 3c minus a. So these sometimes look trickier, but this one was actually easier than these other two. All right, 6, solving for y. Definitely pause. And do that one on your own before you check it. So if we want to get y alone, again, do not touch the guy that's right next to it. That's multiplication and division. We want to do this guy and do addition and subtraction. So that's a positive 4x, so we're going to subtract 4x from both sides. We get negative 3y equals, bring the variable down first, negative 4x plus 9. We're solving for y, so we're going to divide everything by negative 3. A negative divided by a negative must be simplified to a positive. So that becomes 4/3 x, and 9 divided by negative 3 is negative 3. So there's your slope, 4/3, and your intercept, negative 3. We're going to skip over the challenge problems. We can work on those together in class. I do want you to write this in for number 9. The area of a circle is a equals pi r squared. Solve for r. And we'll do that first, and then I'll give you a chance to write the second part. So this is an application problem to what we just did. We need to get r alone, and this one's slightly different because we have the r squared there. So I'm going to show you how to do that. So if we want to get r alone, first I'm going to rewrite a equals pi r squared. R is being squared, but it's also being multiplied by pi. So we want to get rid of the pi first. So since they're being multiplied, what we can do is divide both sides by pi. So we get a over pi equals r squared. So we need to get r totally alone, and the opposite of squaring something is to take the square root of it. So we'll take the square root of both sides, and that square and the square root will cancel, and we'll be left with r equals the square root of a over pi. I'm going to rewrite that. R equals the square root of a over pi. So a little trickier, but once you've seen it, it's not so bad. Now, that is the first step, solving for r. Now for the second part, it says, if the area is 1,000 feet squared, what is the radius? Now the purpose of us solving for r is so we will use that formula down here. So r equals the square root of the area, which is 1,000 over pi. Okay, so we're basically just plugging that value in, and then we're going to throw that into our calculator and find out what r is. So you'll put 1,000 in, divide that by pi, and you should use the pi button so that you can be as accurate as possible, and then push equals. And then take the square root of your answer. So you should get 17.8. The radius would be about 17.8 feet. All right. Again, if any of this was confusing, go back and listen to them again. This is a challenging section. So if you have to do that, that's no problem. That's what these videos are here for.